Hello, everyone. My name's Satyen Desai, and I have a public speaking problem. It's been about 2 months, 14 days, and 5 hours since my last talk. And for some reason, they keep on enticing me back up here with donuts, which explains breakfast this morning. And I want to come up here today to share with you a talk I did internally about 2 months, 14 days, and 5 hours ago, which kind of outlines YUI's approach to the mobile web development space. And hopefully, by the time we're done with the talk, you'll see that we're trying not to think of it as a completely segregated web development space. And it makes sense to treat it like any other web development space, which kind of explains that title slide a little. So as part of today's talk, it's got kind of 3 core sections. For the first section, I'll be going over the philosophy I just discussed, kind of outlining how we really don't think the approach to mobile development, or mobile web development rather, should really need to be any different from anything we've learned over the past 10 years developing for the desktop. In the second section, I'll go over some of the kind of new features which were added to YUI 3.2 in kind of relation to that strategy, which was our first step into the kind of mobile space. And then finally, we'll look at a couple of demos. A couple of them are already out in the wild in terms of the YUI examples. And we'll look at one which is kind of a sandbox area where we're playing with not only the idea of using the same code, the same library across desktops and mobile devices, but also on the server. So make sure we leave enough time for that. After that, we'll basically wrap up, get something to eat, head over to Doug's talk. I don't think he has any problems with public speaking. Never seen him at any of the meetings, at least, so I imagine he doesn't. Mobile and the philosophy of front-end development. So right now, it's a really exciting time to be a web developer. Probably all agree. There's pretty much a new device showing up on the market every month, if not more frequently. And there's lots of things to love about this evolution. I think it's obvious that all these new devices are really, really shiny, and it's obviously why we love them. Having one also impresses the ladies, which helps. But aside from that, the idea of getting applications, experiences, solutions out to a wider array of people and in a wider variety of places is really exciting. On top of that, all of these devices already ship with a runtime which we're all familiar with. Right? It's a runtime where we can write code once, run it everywhere, and have the ability to do that across environments. Right? And finally, the thing which is really exciting about this evolution, is the fact that we can apply all the best practices and principles we've put in place for desktop development, desktop browser development, and apply them to this mobile space. Right? So as a library, we're really hesitant to kind of segregate the mobile web development space and start developing features specifically for it, start targeting it directly. Right? Because if you break it down, a lot of the features in these devices, the features which people refer to when they talk about mobile web development, and in fact, a lot of the constraints, too, are not really mobile specific. There's nothing really mobile specific about them. And in fact, the definition of mobile itself is a little vague, right? Where do you cross the line between a tablet and a 10-inch notebook, for example, right? So rather than treating it as a segregated space, we wanted to treat it in terms of features and constraints. And one of the most obvious set of features which pops up, obviously, is touch support. Right? And classically is an odd term to use here. It's like my 5-year-old saying when I was a little kid, right? But classically, touch support has been kind of grouped into the mobile space. But there's really no reason why the 30-inch, 30-pound monitor on your desk couldn't support touch interactions just like a mobile device does, right? So it doesn't make sense to segregate code specifically to target mobile devices if there's potential to reuse it across all devices. even on top of touch, if you think of things like touch and mouse interactions, they're really device-level interactions, right? As an application developer, you don't really care if someone is doing this with a finger or a mouse or a stylus or whatever comes next. You want your application to respond to this, period, right? And that's why we thought that the idea of gestures themselves could be applicable just as much on a mouse-based device as they are on a touch-based device, right? Again, nothing necessarily mobile-specific about them. And then there's a set of features which, again, people tend to group in the HTML5 space. As we heard from the panel the other day, it's really HTML5 and friend space, right? And even those features, classically, people tend to group them when they're talking about mobile devices. But here again, the idea of leveraging CSS transitions under the hood for more optimal animation effects really applies just as much to a desktop or laptop environment as it does to a mobile environment. The idea of providing offline cache support for someone lugging around a 17-inch Dell in Malaysia somewhere with reduced latency, increased latency and reduced bandwidth connections applies just as much as it does to a mobile iOS device. Right? Same thing with single-page history management, for example. All these features, although they tend to get grouped under the mobile umbrella, aren't really mobile-specific. On the other side of the fence, there are definite realistic concerns about performance or the performance constraints which this new set of devices introduces. Right? The idea of K-weight being a factor, for example, especially in terms of the latency impact and the bandwidth impact. But again, there's no reason here why optimizing K-weight for the library in general, as opposed to targeting a mobile-specific subset and trying to target that set of features, improves the performance for that guy running around in Malaysia with his laptop, right? It helps overall. Same thing for runtime performance, right? And runtime performance is even grayer. A certain subset of these devices probably perform better in terms of rendering and JavaScript execution than IE6 running on a mid-level laptop, right? So anything we can do to optimize runtime performance for the library as a whole benefits that entire set of environments we're hoping to target, as opposed to concentrating on a mobile-specific solution. And the final real one is kind of the real estate picture, right? There's obviously a different interaction you want to present for the user when they're dealing with a limited screen real estate, right? A 4-inch by 2-inch screen real estate. But even that, I don't think is mobile specific, right? If you think of interacting with a web device on a TV, for example, a 65-inch TV sitting 10 feet away from you, that type of UI would feel right at home in a mobile environment, right? Big targets to hit, page transitions, that kind of stuff, right? The kind of UI you work with when you're dealing with, a Wii or a PlayStation or whatever, right? That UI makes sense across the board. And again, that whole problem is not mobile specific. So that's kind of on the idea of not treating mobile as this separate, isolated space and optimizing for it, but rather picking the features and the constraints we think are important to address and rolling them into the library as a whole, right, in an effort to make the library better. The second concerning part about kind of the recent development and targeting towards mobile web development is the idea that it's okay to develop specifically towards one particular browser or one particular flavor of browser, right? WebKit Mobile being the favorite one, right? But as we heard from the panel talk yesterday, I mean, these newer set of browsers, touted as HTML5 browsers, they're still based on something which is a draft which has potential to change. And in and of itself, just the business environment around them, regardless of whether that spec is stable or not, there are going to be business factors which drive one browser over another to make certain decisions in terms of feature sets supported, how they support them, etc. Right? So even in the HTML5 world, you're not dealing with a perfectly homogeneous environment, and it's likely that you never will be. Right? PPK and John Resig have some interesting stuff to say on that whole problem. But even when you move outside of the WebKit arena and start thinking about other mobile-based browsers. PPK's dashboard lights up like a Christmas tree, right? So there's still a massive variation in environment. And I think, at least me personally, I think the business environment in play, which creates that, will continue to exist regardless of standards or not. So the one thing we're really hoping to move away from, right, is this idea that I'm tailoring a mobile experience specifically for the iOS set of devices. Right? It may potentially be okay for docking stations, and even that is debatable. Ideally, I'd like any music-generating device to be able to plug into a certain set of speakers. But it's definitely not okay for the web. And the funny part is that there's nothing new here, right? It's the same set of lessons we learned from 10 years ago, right, when we had websites targeted to one particular browser.
You got a red light on there?
Nope.
Time
Oh,
out.
there we go. We got it.
Check 1, 2 in the back.
Is that the room speaker? Oh, you guys haven't heard anything I've said so far? You guys must be waiting for the food. Anyway, hopefully the slides made sense. So yeah, again, I mean, the whole idea of, or the whole drift toward going back 10 years and starting to target a particular device for your development just doesn't make sense in the same way that it didn't 10 years ago. Right? And the arguments on those last two slides, you could argue are web purist arguments, and I'm not a web purist by any measure. I need Matt to come and slap me on the back of my head to clean up my markup. But even aside from the philosophical arguments, right, there's the business or product development argument. And when you start generating hundreds and thousands and tens of thousands of lines of code which start to target one particular environment, when the new kid on the block shows up, and I by no means am saying that's the new kid on the block, but when any new kid on the block shows up and starts being the most popular environment for people to be targeting, every single one of your lines of code has to go, you have to go over every single piece of code you're looking at which works against that environment and start modifying it, right? And that's a major cost. And again, there's nothing, there's no rocket science behind this, right? It's just basic software development. You want to protect yourself from the things which are likely to fluctuate the most, right? And that's why the introduction of an abstraction layer for mobile development makes sense. It continues to make sense just like it does in the browser environment and just like it does in any other environment where you don't have control over the environment you're running code in. Right? It gives you a buffer against fluctuations in that environment. And the reason we think YUI is a good fit for that abstraction environment, I mean, that bar could be any abstraction layer, right? It could be any library you work against. But the reason we think YUI is a good fit for it is sorry, I skipped forward a little there. But the idea being that when the new kid on the block shows up, that the abstraction layer is the only thing which needs to change going forward. Your tens of thousands of lines of code don't need to change. They work against the same API. They do the same thing they used to. And the abstraction layer takes care of identifying and normalizing that new environment for you. To get back to the YUI point, right, the reason YUI 3 is a good choice there is because it's the same API you're familiar with to develop your desktop applications, right? You're already familiar with that environment. There's no reason that any of that code couldn't work on this new environment, given the abstraction layer in place. And I didn't have time to dig up an image, but with the advent of Node.js and YUI 3 running on Node.js, that list of environments just gets bigger, right? So now you have the same API, which you're already familiar with, working against, have code deployed against for the desktop browser set, now just works in the mobile environment and just works in the server environment too. We'll look at that in some of our examples later on. Right. And I think the argument here is really, really basic and really, really fundamental, right? There's the native app development argument versus the web app development argument in the mobile space also. And I think the idea that we already have a runtime in place which is available on all these devices, right? We have a place where we can deposit our code, deposit our experiences, deposit our solutions, and extend the reach of those solutions, right? Without any additional or without any substantial cost and without increasing the time it takes to get those solutions to market, right, is a big selling factor. There's nothing surprising about that. And additionally, with the introduction of the abstraction layer, your maintenance costs are reduced, like we saw in the last slide, where when new environments do crop up, as long as you're programming to that interface, there's nothing you need to change in your application code for things to work. Right? So I think that's a pretty straightforward argument, and it makes sense to kind of not think of the mobile space as something unique. And there's a lot of stuff in terms of the YUI3 architecture, which we'll get into, which not only can help you target new environments as they come up, but also helped us refactor the library when these new environments came onto the scene. So YUI 3.2.0 was our first step kind of towards addressing this new set of devices on the market. And the features we introduced were kind of directly in relation to that. The capability-based loading support, we'll look at details a little later, kind of addressed or tried to address the k-weight factor, right? So as we were developing the library up till now, internally in terms of implementations, we might have been doing load time forking to say, if this is IE, introduce this normalization layer. If it's Firefox, introduce this normalization layer. If it has this set of features, introduce this normalization layer. If it has that set of features, introduce that normalization layer. But the introduction of capability-based loading really helped us formalize that in our code. And that, on top of the sub-module infrastructure, which already exists for YUI3, was something which we could easily roll out and implement without a massive development cost. Transitions was, again, the idea that we'd like transitions to be available both in the mobile world in these new devices, but also on your desktop browsers and also across the entire A grade, right? So we wanted to support transitions, the ability to work through that same API across the entire A grade matrix. The touch, mouse gesture support I described too, and we'll get into some details on that. We introduced a scroll view widget, which the mobile team internally at Yahoo contributed to YUI. It was a port of an implementation they already had. And that was one kind of key widget gap in the mobile space. And that's working out pretty smoothly. Drag and drop was ported to sit on top of this gesture layer as opposed to being hard-coded to click or mouse down. And that essentially gave us drag and drop support for free with, again, very little development cost. And then we also introduced the idea of leveraging local storage in the browsers which have it available, and also the idea of adding HTML5 support to history. And the development pattern there, again, kind of highlights the architecture or the flexibility of the architecture of the library. It was really architected in the same way that we architected data storage, for example, in the YUI2 release, to say, we support a history API. If your browser supports history APIs natively, we'll use them under the hood, but that doesn't mean that we should rule out all the rest of the browsers. We can still use older techniques to support those browsers and give you A-grade support. Okay? And that whole philosophy kind of flows through the library in general. So let's take a quick look at capability-driven loading. Loader and the whole kind of instance YUI use load construct is, I think, one of the most powerful parts of the library, right? And it's extremely flexible. You have the choice of choosing your loading strategy on both ends. So you could say, I have a certain amount of content which I can deliver to the client. They can start leveraging it, even if they don't have the entire set of JavaScript they need on the page to enliven it. In which case, I might want to populate the page with a lower upfront seed cost and then introduce JavaScript to the page and CSS to the page, either as the user interacts with stuff or incrementally while they have access to this content which is already on the page. On the other end, you could say, I know the entire set of requirements which this page is going to need. I'm going to need most of them up front. Let me create one single blocking request for them, get them all on the page, and I can start leveraging stuff that way. And that gives me the optimal experience in terms of blocking script nodes added to the page. So in and of itself, that's powerful and flexible enough. And with the idea of capability-driven loading, it's taken a step further. And not only does it take kind of loading a step further, but also lets us implement our modules and submodules in a disciplined way so that we're providing the lightest level of abstraction we can for browsers which support it, the native set of browsers, and then we can conditionally layer on code on top of it, which normalizes for IE and Firefox and all the rest of them, right? And again, here you have two basic approaches, right? I mean, there may be scenarios, say you've got a startup scenario and your boss says, I need to deliver this iPad solution in the next 2 weeks before we run out of money, right? You still have the ability to say, yeah, only give me the code I need for browsers which support transitions and selectors natively. Drop those on the page, right? And that part is pretty straightforward, right? So when Matt started writing transition, because we introduced this idea of capability-driven loading, he could say, I write my transition layer as light as possible, targeting native support wherever it's available. And that's my base layer. That's my transition native module. And then if people want IE or Firefox support, they can pull in the whole transition module, which introduces timer-based support for browsers which don't have native CSS transition-based capability, and fills out the A grade for you, right? So in that startup scenario, once they've got their round of funding after that 2 weeks, and they decide they want to support IE and Firefox, their application code doesn't have to change a bit, right? They don't have to touch their application code. The only thing they need to change is that use statement on the browsers which require it to say use transition instead of transition native. And since they're working through the transition API as opposed to directly against the browser, it'll normalize for them under the hood. No code change required on their part, right? What we were talking about with the slide a little earlier. And again, even in that scenario, you have the option to let Loader handle that. So you can tell Loader, give me DOM style, for example, and Loader can be given conditionals which say if this if condition is met, this should be the dependency list to include, and if not, this should be the dependency list, right? So in this case, DOM style IE, the module metadata for it, specifies IE as an environment requirement for it to be loaded on the page, or not a requirement, but the fact that it needs IE, or it's only required if IE is the environment you're driven against. So if you ask Loader for DOM style, if it's in an IE environment, it'll load the base native implementation and then layer DOM IE on top of it. And if it's not IE, it'll just give you the base implementation, and you don't have to worry about managing that weight. And the conditionals Loader uses don't necessarily have to be environment-based, right? They can be feature-based tests. You can give Loader a function which says, execute this function, and depending on the results, load this module or don't load this module. Right? So again, further enhancing the power of Loader. Another part of Loader we're looking at, and this is more in relation to runtime costs than actual K-weight costs, is the idea of moving the logic behind the dependency management. So when you use Loader and ask it to do all the dependency handling, it has to go through the dependency tree and figure out what set of modules you really need to be added to your Y instance. And we're looking at the idea, the API, I believe, is already in place to support a remote Loader service, so that if you have an implementation and we're working on deploying something along those lines, if you have a remote implementation on a server which understands what to do when you tell it that you want to use scroll view on the page, it'll do the dependency calculation on the server for you and deliver the right script as a result of that. And so on the client side, you not only save in terms of the metadata footprint which you need to download and use, but you also save in terms of the runtime cost required to evaluate that metadata. And then a final thought on kind of loading in general. right? If you think about native app development, even for native apps, there's an initial startup or download cost, right? You go to a native app page, you download the native app, it downloads the bytecode required to run the application, right? And then after that, incrementally, you can request data over the wire for the dynamic experience, or you can upgrade it to get new features, to further proliferate it. And it would be nice to have that flexibility in the web app development environment, right? And to a certain extent, offline cache gives you that, right? You can say, I've got this chunk of code which I need to drive my application. It's largely static. It's not going to change. When I deliver it for the first time to this client, why don't I just ask it to offline cache it, right? Because browser-based caching is not too dependable in general in this environment. Why don't I save it on the device? And then after that, I can use the locally saved copy in offline cache and just go out across the wire for the incremental feature set I need or the incremental data I need. And the Mozilla web app kind of prototype, which Tamtek referred to yesterday, is another kind of promising, I think, movement in that direction, where you not only have the offline cache capability on the client, but then you also have the discoverability and the ability to monetize it on the server and all the rest of the stuff. So transitions, the other kind of big feature for 3.2. When working with transitions natively, right, again, because HTML5 is still a draft and there's potential for there to be flux, all the browser vendors who want to implement it need to implement it based on vendor-specific prefixes, right? So when you're dealing with it, or when you're dealing with multiple HTML5 browsers, you have to deal with all of those vendor-specific prefixes individually. And what's even more cumbersome than that when dealing with transitions on the JavaScript side of things is the fact that you have to map, couples of transition properties to durations, to easing functions, couples or more, however many properties you're trying to transition. But you need to make sure that the duration, you have durations for each of them or defaults you're comfortable with, timing functions for all of them or defaults you're comfortable with. So there's a lot of string management to parse that in and out and trying to get your transitions to do what you need it to. And the kind of same vendor prefix CRUD flows over to the CSS side of the fence too, right? You still need to account for vendor prefixes, not only in specifying the property, but sometimes also the value, right? And after doing all that work, at the end of the day, you only have partial A-grade support, right? You're still not supporting Firefox 3.6 or IE, for example, right? With the transitions interface in YUI 3.2, it groups transition properties logically as you'd expect to use them, right? So you want to animate left, you want to animate top. You don't have to worry about manipulating strings and mapping them to a duration and an easing function. You can group them logically just through code. Plus, under the hood, again, based on the module which is loaded, you either get native support if it's available, or for browsers where it's not available, it can fall back to timer-based support. But as an application, you still have transition functionality regardless, right? As part of 3.3, Matt enhanced the transition support to support the idea of grouping commonly used transition definitions by name. So you can set up a name transition and then invoke it on node instances, reuse that name across node instances, kind of like applying a class and having transitions click in. And then the final set of feature support I wanted to touch on was literally the touch support. When we started looking at touch support for the YUI library, we really didn't want to go down the road of multiple components, each having to do their own, is this mouse-based interaction or this touch-based interaction analysis, right? And if it's touch-based interaction, is there one finger down or are there two fingers down, et cetera, right? We didn't want drag and drop have to do that, and then scroll view have to do that independently and have replicated code in multiple places. And that's where the idea of kind of gestures came up to normalize that interaction. Sorry. And again, kind of going back to this idea of the flexibility built into the library itself, Adam and Luke already have a synthetic event infrastructure in place. Luke refined it for 3.2, I believe, to make it way easier to use. But based on that synthetic event infrastructure, and the idea behind that, if you attended Luke's talk, is to publish events which look like DOM events, which you wish existed or which need normalization. And under the hood, you can take care of everything else. And again, the value there was that since that layer of abstraction already existed, the only thing we had to do for this touch mouse-based normalization is figure out what to do with the event facades coming in, which set of properties to normalize, identify one finger or two fingers, etc. And then support for the gesture move synthetic events and the flick events, which encapsulated that mouse versus touch logic. All of these events already had built-in support for delegate and once and things like that. So if you look at the gesture swipe example on the website, for example, it uses the entire array of event sugar, if you will. So it goes through delegate, it uses once, it uses fire once, I believe. And all of that is just available for free without me as the developer creating a move gesture or flick gesture, having to worry about how am I going to support delegate and how am I going to support once and how am I going to support fire once, right? So that's the power of kind of the synthetic event infrastructure underneath all of this. And as a result of this, as an application developer, as I mentioned earlier, what I can do is code towards the gesture as opposed to device level specifics. Right? So as a developer, all I need to do is say, my application needs to respond to that. It needs to identify where the start happened, where it's moved to, and where the end happened, right? Regardless of whether that happened with a mouse or a touch device. So I think that kind of wraps up the first two sections of the talk a little earlier than I expected. Look at a couple of demos right now, and we can get into looking at some code too on the Node.js side of things. See if it's visible. Okay, so this is the out-of-the-box drag and drop example in YUI 3. It's exactly the same, in YUI 3.2. It's exactly the same example which existed in YUI 3.1, YUI 3.0, for example. Right? Nothing about this example needed to change to be able to support touch versus mouse. Underneath, DD was refactored to work on top of the gesture layer. And as a result, I have drag and drop for free with mouse-based devices, right? And we'll look at the touch-based interface a little later, just switch once, right? So I have mouse-based input for DD, but I also have touch-based input. And what's interesting about that is that it's not just part of DD, right? The way YUI is architected, the application logic for DD all sits inside the DD class and the set of supported plugins for DD, so proxy, constrain, etc. So I get all of that support once I abstract out the idea of whether I'm interacting with it with a touch or a mouse button, right? So again, looking at it as library developers, it reduced the cost of development for us, and that same thing just bubbles up to application development. So for example, sitting on top of DD is Slider, and Slider just got all of this for free without any development cost, right? It got touch support without doing anything. Luke woke up one day and found touch support working on the Slider. Right? Simple as that. Same thing for the scroll view, right? So the gesture is not popular. I'm getting used to it, but it's not popular in general. But there's no reason it couldn't be, right? Why couldn't I go to an image carousel and flick my mouse and be able to flick through images, right, on a desktop with mouse support? And again, no extra work was required to support the mouse versus touch support for this. Built on top of the gesture layer, that takes care of which pointing device is initiating this interaction, and the rest of it is generic code. Okay. And then The more interesting example, so these examples are obviously out there, and you can take a look at the implementations in the source code. More interesting example, excuse the picture quality, that's just a function of the data I'm building it on top of. But so for this example, same thing again, it's a more real-world application, right? But you have a scroll view which you can interact with. The scroll view has an API behind it, so you can respond to events in the same way you'd do for any other YUI widget, and using attribute change events and custom events, which is what I'm using to power the pointers on the end. I can use the out-of-the-box tab view, obviously, on the desktop, and everything is good. I also have incrementally loaded drag and drop. Oops. Let me refresh that. There should be drag and drop there with, yeah, there you go. So sortable list support, constraint support, right? And that obviously all works. We know it works. It's worked for a long time now, right? But take that whole set of examples over to the touch interface. I should have done my nails today, but right, that same code again. That exact same example code, which was in place for 3.0 and 3.1, just works on touch. There's no development cost required to move to it. Right. Looking at the scroll view example, right, that its main target environment was a touch environment, so you'd expect that to work. Oops. Going back to the full-blown example, right, you've got touch support there. You've got the tab view. Again, none of these components really know whether they're running on the laptop or the tablet or an iPhone, for example, right? The application code looks exactly the same, right? And you've got drag support, again, with the entire feature set of drag and drop, which is not trivially implementable, right? So scrollable list sorting, constraint support, proxy support, all of that stuff for free just by changing out that abstraction layer underneath for the input devices. Switching back to here, right? So, we looked at Chrome, which is a WebKit browser. Again, same thing applies for Firefox, right? This is 3.6. So you get all of that support for free, including this example. Oops, something with a drag drop implementation. I messed it up, but yeah. Right, so you get that entire feature set on whichever environment you choose to run on. And the more interesting part about it is that for this particular example, on the server, I'm using YUI2. So this is hitting my Node.js instance under the hood, which, if you remember back to Dave's talk, the first talk, he talked about YUI Express and the work he's done to get YUI working inside Express so that you can have a YUI instance not only available on Node.js, which the Node.js YUI3 module provides, but also bound to the page you're trying to render. Right? So in this case, I can load YUI on the server, right? Use it to do whatever server-side logic I need. So in this case, I'm leveraging YQL. I'm sending out 5 requests to YQL. They're going out in parallel. Node is doing its stuff under the hood, under Dave's Node.js translation layer to send out the requests in parallel. They'll all come back. Whenever they come back, when I get them all back, I'll send out a response to the client. Right? So I'm using this as an instance on top of YQL. I'm using substitute for my templating, which again is already something you're familiar with on the client side. I'm using data type date, which under the hood uses the language pack support to pull in a language pack for a specific language. Right? And I'm using this to formulate the date, for example. So hopefully this should work. Oh, I still need to restart stuff. But once that's done, the date, which is previously being formatted for yen, right, should show up formatted for FR using the language pack infrastructure, which already exists in YUI. Now, so I have the entire YUI toolkit available to me on the server. And if you look at the YUI toolkit, a lot of it has nothing to do with a browser, right? Things like base and attribute can be leveraged just as much on the server as they can on the client, right? To manage state, to get attribute change events, to react to attribute change events. A lot of the utility infrastructure, like the formatting, for example, or the data source infrastructure, or any of that makes just as much sense on the server as it does on the client, right? So I'm picking up partial templates here. The other neat thing about it is that I have my choice of templating infrastructure, right? So I can choose to have a straight up page, no tokens in it, and use YUI support and the page binding support, which Dave added, right? To do stuff like this to work with those templates. Oops, sorry. Right, so I can pick up content from that template and that page and act on it just like it's a DOM. But then I can also fall back to strings if I wanted to and say, you know, I want to do my templating through strings. I've got this template definition with tokens, okay, and I'm going through substitute to actually do my token replacement based on the data I get back from YQL and render things as strings. Okay. So after I do all my legwork, I send out my request to YQL. SY is the server Y instance, so it's the instance I'm using to do my server-side application logic work. Right? So I send each of those requests out, wait for them to come back in. When they come back in, render them through the templates. When I'm all done, I send back the output to the client using the templates I have in place. And I can modify the page on the fly. Something which would be tedious in most other templating environments. Right? I can also use the conditional partial support Dave's got in place to say if I'm rendering for a mobile environment or in particular an environment which supports iOS as meta tags, for example, I can deliver this additional content to the page, right? So that when I'm on this device, I get the whole mobile experience. This is one I did earlier, right? I can conditionally load my script. So for example, for the Firefox example, I needed to load non-native implementations of transition, for example. So I can customize what I'm delivering to the page based on that to get the, oops, 1 second, sorry. Right, to get the Firefox experience. And the best part about it is that my PHP is terrible, right? So is a lot of other stuff, but my PHP is definitely terrible. And I really didn't have to learn anything about Node.js. I really didn't have to learn anything about PHP to get this done, right? I know YUI. It's the same YUI I use in the client. I needed to ask Dave where to put this line, and that was about it, right? I'm responding to YUI-FP. From there on, it's all YUI. Right. I think that's the ideal we want to get to. As Dave would say, it's huge. But right, so we're using this application as kind of our play around sandbox. I think it's not ideally where I wanted to get it for the conference. For example, I wanted to take a look at packaging and say, if I want to package one of these things, one of these pieces of rendering logic or application logic as a YUI module, and then have the choice to run it either on the server or the client, that would be ideal. Right? So we're going to continue to play with this. We'll put it somewhere for you to get at and look at and mess around with yourself. But it provides a good kind of proof of concept for same code on the server, on the client, on whichever type of client you're choosing to target. And it all just works. There's one more piece of the demo. Sorry. I think the other key takeaway, moving away from kind of Node.js and back to the whole kind of F2E thing and the hats we wear as F2Es and the best practices and principles we've learned as F2Es over the last 10 years, right? This whole page, if I ask for it just as a hack, you see that? Under the hood, we're supporting a mobile environment, but it's still using the best practices we already have in place based on progressive enhancement to deliver content, right? So not only do you have access to the A grade and you have a baseline C grade experience, but you can also refine your experience anywhere along that line to target, mobile devices with certain characteristics or not. Right? So you can start adding pieces to this to build it up. But the point is, this is much, 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 much better than saying, if you have WebKit on iOS, we'll support you. Otherwise, you get nothing, or you get the experience designed for someone else. Right? Establishing the C-grade experience lets you build up from it to target whichever set of devices you want to target. And again, there's nothing new here. These are principles which have been in place before YUI existed, right? It's just not giving up on them, not casting them aside, following them going forward. I mean, it's as simple as that. I think that's about it. That's really in terms of the mobile experience debate, whatever you want to call it. That's all I had to say, and I think there's a compelling argument there. There is a need, there will remain a need for abstraction layers to provide future compatibility so that when the new hot device comes out, you're not taking a massive amount of code refactoring cost in order to support it. We have the idea of code once, use anywhere already defined. We don't need to redefine it, right? We have HTML for content, we have JavaScript for behavior, we have CSS for presentation, and all these environments support it. There's no need to reinvent it, to normalize across native app development or whatever else, right? There is an environment there, you can use it. There are definite downsides, right? There are trade-offs in place. You definitely have better runtime experience with native apps. You definitely have access to a bigger feature set with native apps. But I think it's not worth letting that drive the whole discussion, right? You need to trade it off against how can I expand my reach by using technologies which I already know I can deliver to a bunch more clients, right? How can I get an experience which is close based on those technologies? And the way I see things going, based on kind of what we see out there, plus what was discussed in the panel yesterday, you look at Chrome and they come out with a new release every week, really. Up until last week, I thought I was on 5, and when I looked, I was on 7. Right? So I don't really think that gap we were discussing as part of the panel conversation yesterday is really as big or as slow to catch up as it once was. Right? It's definitely going to be faster for the native environment. The things are going to be bundled together, right? The software and the hardware experience. But there's no reason that the browsers can't catch up along that level of play. There's no reason they can't catch up in terms of performance, right? I mean, JavaScript's interpreted, it will always be slower than something native compiled running on the device. But that's a trade-off you have to consider, and consider the fact that are you willing to spend the investment to develop native applications for each of these various environments, develop the skills for each of these in various environments, or can you get close enough with a web experience? And the final point, which I think is a good segue into what I wanted to talk about next to kind of close out everything, is that if we can all agree as a community that that single abstraction layer is the right thing to do, I think there are things to fix there, right? We need to fix the performance issues. We need to fix the K-weight issues. But that's not a reason to throw out that entire solution when we know it's the right solution to follow going forward, right? And that's where I think the community can really help specific to the mobile work, right? I mean, if you look at my phone, I'm in no way, shape, or form the right person to be defining what the cutting edge is of mobile devices, right? And I think we have a lot of experience in-house and externally, which can help contribute to making that normalization layer as optimal and as light and as flexible as possible for these new devices as they come out, right? So I think that's the key takeaway for all of this, is that if we can decide that abstraction layer makes sense, let's work to make it as performant as possible so we can get an experience as close to the one we want as we can. Finally, wearing Eric's hat here, I think he normally does this, but since this is the last talk for YUIConf, I think the whole idea of a conf, the whole reason we have a conf is because we have a community, right? If it was just the 8 of us sitting in a room, we'd just be eating donuts and churning out code, and a couple of us might end up getting injured. But the whole reason we have a conference is because we have a community which is interested in contributing, interested in providing feedback, right? That slide's a little dated, by the way. That's from my talk 2 months, 14 days, and 6 hours ago now. But you can see that the gallery is a big part of that model, right? We've got the core layer, and even the core layer is not really defined by developers. It's not core because this set of 8 developers work on it, right? It's core for the reason Eric mentioned yesterday, I think, if you're here later at night. It's core because it's the basis on which everything else is built, right? So we need to guarantee a certain amount of stability, a certain amount of continuity, and a certain amount of on-time delivery for that core, right? And if you're willing to buy into that, there's no reason that you can't contribute to the core, right? If you're willing to have a national record-holding power lifter there bang you over the back of the head to deliver stuff on time, there's no reason you can't contribute to the core. I mean, Luke is a better person to talk about the community than I am, but from the people I've worked with, the Anthony Pipkins, the Erics, Nate and Eduardo, there's no reason that any of those guys couldn't be contributing code to the core, assuming they're willing to deliver on time per George's schedule, right? And then outside of that, there's the gallery, right? And that's where kind of the innovation happens, the flux can happen, and that's where we can iterate over ideas, cutting edge, implementations, all the rest of that stuff. And because it's integrated with YUI, because it's integrated on the CDN, it's integrated through your instance, through your loader, it's trivial to use it in any application and wait till it develops and becomes part of the core library and buys into that whole kind of stability mantra, right? So, I mean, the stuff is out there. We could definitely use contributions, like I mentioned, on the device front for sure, but also, varying forms. There's people who contribute to the forum and provide a great amount of value there. There's people who can contribute on documentation, examples, once we have this new site infrastructure in place. And then there's code and components, right, and bug fixes and patches. And if we want to scale, we need the community to get involved. There's no other way around it, right? So this conference was for you. Hope you enjoyed it. I think we'll call it a wrap and go listen to Doug. Talks better than I do.